Hello and welcome. It is time once again to try to fix something, and today on the workbench I have a PS5 digital edition, which I believe is a no power, and we will find out shortly. I've got it connected back there, power and HDMI. Let's just get right to it. What does it do? What does it not do? Okay, rather dead. Rather dead. Will it be a simple power supply issue? Will it be a horrible motherboard issue? Let me get into it and we'll find out. Okay, I like how this is starting off. Nice and sealed. I like that. I like that. All right, I have swapped in another power supply. Is it going to make any difference in the world? Let's see. Yes. Okay, well, that's good. So we just have a dead power supply. That's easy enough. Make sure this thing's going to come on up. Some video maybe? Yeah, I've got HDMI connected. There we go. Come on. There we go. All right, so we have a dead power supply. Well, that's good. Okay. We'll take this inside and see if we can make it work once again so I can hang on to my spare power supplies. We are inside at the workbench. Ready to take a look at this PS5 power supply. And I have spared you the agony of watching me suffer, struggle trying to pry this thing open. But it's all done, so we're ready to just get right to it. What is going on with this thing? Just a simple blown fuse. These fuses never blow. Nope, still not blown. Make sure that's in the, yeah, you can see that meter. All right, did we blow some MOSFETs? If we did, one of these this resistor here should be open. No, we did not blow the fusible resistors. So that make me think that the MOSFETs are probably okay. Well, that one does not seem to be shorted. This one does not seem to be shorted. Okay. What's going on with you? And I'm assuming we don't have any shorts. I mean, if we had a short across the main filter caps here, the fuse should have blown. Although I probably should discharge this thing just to be sure. That's the safe way to do it. Just see, do we have a charge on these caps? We do. A little over 200 volts right there. Well, it tells you the main fuse is good. It tells you your rectifier is good and your capacitors are good. So why doesn't it work? Probably a dead DAP53. Let's look at maybe some diode measurements around that DAP53. Although I need to find my notes. Okay. Start with pin 1, 0.71. That's just fine. Pin 2, 0.58, that looks just fine. Pin 3, 6.8, that looks fine. Pin 4 is ground. 5 is 662, looks fine. 6, that looks fine. 7 is not connected. 8's like the 1 volt one, yeah, 1.48, that looks fine. And this one's also 1 point something, isn't it? A little lower than usual. That's normally 1.16, a little bit low. Okay, about, where was I? That was 9, this is 10. That looks normal. 13. A little lower than, wait a minute, how did I get to 13? 9, 10, 11. I don't know why I jumped to 13. 11. That looks a little bit lower than normal. 14. I mean, dang, I don't know why I'm skipping numbers. 12. No connection. Now it's 13.7. In the ballpark. 14.62 in the ballpark. 15.70, yeah. 16.68, okay. So only a couple of them look suspicious there. Number 9. Well, okay, now it reads normal. I wonder if there was some charge somewhere. That was reading 0.9 something earlier, and now it's 1.13. And 10. Yeah, those two aren't shorted, are they? No, they're not shorted each other. Okay. So we don't have any shorts on the DAP53. I mean, nothing dead shorted. Nothing obvious. So is this a case of it shutting down? Possibility. I was looking at these resistor dividers here that seem to give us some trouble here. 7.5 megohm. I mean, there's no burn marks anywhere on this thing. There's no roaches. It's clean. It's not going to be anything that obvious, although there could be a part blown to pieces somewhere, I suppose. Okay, I guess it's time to probably apply power to this and see what we get. Just kind of curious, like what we'll get across our capacitor. Will we get 400 or will we get 170? I'm gonna get my meter right across there. She's got about 11 volts right now. I'm going to apply 120 volts AC. Oh, that looked normal, but then we shut down. It looked like it went to 350 and then shut down. $360. Slowly bleeding off. I think likely just a bad DAP53. And it's shutting down, I'm supposing, because the voltage is not coming up as high as it should. It's not making it to 390, 395, 397 is what it should normally get to. Yeah, 360 for a peak there. Okay. Let's just discharge this. 354 volts is what this little box showed. Sometimes I like to reverse the leads just to check. So that's rather discharged. Okay. I will disconnect our AC in, even though it's switched off over there. I'm thinking go straight for replacing the DAP53. DAP 053 has been changed out, and we're ready to check this and see if we've done any good. I'm set up. I have my load connected, as you can see right there. And I've got a meter across the main filter caps just to see what kind of voltage we get there. Turn on some AC and see what happens. No. We did not come up. And our voltage only went to like 310. I have the AC off right now. I'm going to turn it back on. I want to see if the 12 volts even bumps for a moment or not. There was a little bit of current, so it tried to do something, but it shut down so fast. Try it again. Yeah, I see like 340 volts across the capacitors here, just for a moment. She's trying to start, but she's shutting down. And we replaced that DAP 053. So we have another problem. All right, so we're going to have to dig a little further into this power supply, and I've got my notes here, fortunately. I think I may have found an issue that might cause it to shut down. We're in diode mode here. And I'm going to put my red probe on the negative terminal of the large, bulk capacitors. And we are fully discharged. I've discharged it completely to make it safe. So red probe is on that negative terminal. And I've got some diode readings down through on these opto oscillators. If I start at the top here, I have that as being infinite. It looks like it is. Next one here is says 0.7. I'm showing 0.5, so I have to keep that in mind. Could be a problem. Here, that's ground, 0 volts. That's normal. 0.683. I got 682. This one says infinite on the top of this one. I think I got these numbers wrong. Or I've got the board turned different. Yeah, that's my problem. I've got the board turned like this. Okay, that makes sense then, maybe. Or is it? I'm confusing myself. No, I think I just got the numbers wrong. I think the position is right. And then this one here. I'm confusing myself here. 51. Okay, let's just turn the board. Maybe I had it turn like this when I made my notes. Is that right? No. Oh, this was made from a DR. And this is an ER. So I think they changed the position of some of these opto-isolators. Ah. I thought they were the same between the boards, but I don't think they are. But this one here, this last one, which I'm not sure what its number, it looks like it's going to be IC51. Yeah, this should be 51, IC51, IC53, IC52. On the cathode side of this LED here, I've got a short to ground. I don't think that's normal. I need to make some notes for the ER. I don't think I have any with an ER. That's shorted to ground. I don't think that's normal. And I see what's connected to it here. It looks like it's one of these small MOSFETs marked W4R, which is a 2 in 7002 of a type. It's a regular 2 in 7002 W4R. I think it may have shorted to ground because here's one terminal of it. I think the other side of it is ground. I think it's shorted through from drain to source. Gate's not shorted, but it looks like drain to source she has shorted. I'll give you a look under the microscope if I could. There's the opto isolator in question. And if I check down through here, you see this leg here. This would be the anode, pin 1. This would be the anode of the LED in there. This would be the cathode side of it. And now it's not shorted to ground. Okay. I think our MOSFET was playing tricks on us. It got biased on. It was latched on. It's no longer showing. Interesting. Alright, well, I have been fighting with this power supply for longer than I care to admit, but it's been hours. I think I finally found the problem, and I should have found it probably a lot quicker, although I've just never seen this issue before. I've even been, I broke out another identical supply, another ADP 400ER to make comparisons to. And if I can show you what the basic problem is, if we look at our output terminals, we have a dead short across our 12-volt output terminals. And I think about the only way that can happen is that one or both of our MOSFETs here have shorted. Now these are being used basically as rectifiers, is my understanding. They're being used to, you might say, rectify the output of this transformer, switching transformer over here. So if they short, you end up shorting your 12-volt rail, back through the transformer to ground. And I think it's what happened. I'm not sure if just one of them or both of them have gone, but I'll have to lift them and we'll just see how much damage we've had. Well, our MOSFETs are out. Let's give them a quick check here, if we could. That's pretty shorted, even shorted over to the gate. Okay, how about this one? Also shorted drain to source. It did not short over to the gate, but still, I don't think it's any good. And apparently, it looks like Mouser does have these parts. If you can see the number on it, I've got two different supplies here, and there's two different numbers, two different manufacturers in there. But it is going to be a IPA 032N06N3. They're about $3 each from Mouser. They do have a few in stock though, so I'm going to get some coming this way. I've never seen these fail on any of the PS4 or 5 supplies I've worked on. I've never seen these output MOSFETs fail, but I suppose anything can fail. Well, let me get those ordered and we'll see if we can complete this repair. Well, FedEx has come through and delivered some MOSFETs from Mouser. So we're ready to try to get this power supply fully repaired and maybe get it back in that console out there. Well, our two MOSFETs used for rectification have been changed out over here. And I think we're at the point of testing the supply. I do have a meter across the main filter caps here to see what that PFC boost voltage makes it up to. I have my load turned on, set for 4 amps, I think. Yeah, let's see what happens. Hey, there we go. Yeah, this settled at 396, 11.97 over there. Let me just check it right here. A little more accurate reading. 12064. That looks good. And we will run the current up a little. 6, 7, 8, 9, 10 amps. All right, we're running fine, I believe. 10 amps of current. I think she's ready to go. Ready to go back in the housing, and we'll reassemble this console and see if it all works together. We are back out in the garage, and this PS5 digital is fully reassembled. Our repaired supply is installed, and I think I've got everything connected. Yeah, let's just see if she still works. Flashing blue light. That's a start. Video. Yes. Okay. She's looking good. I think this one is back from the dead. Another PS5 saved from the scrap heap. Just a simple power supply repair. Well, if you liked that one, thought it was somewhat interesting, educational, or just funny, please give me a thumbs up. And I will see you in the very next repair. So long for now.